So this video will be on the review for our upcoming test, which is on Wednesday. So the first question is, can I record all the answers to the review sheets in today's video? Well, the answer is yes and no, because remember, the review sheets that I created, is really just based on all the previous videos that I have made from lesson 7, 8, 9, 10, 11. So the review sheets questions is really just a guideline in helping you to find out the key informations or key ideas from the previous videos that I have just made. Second question. Why are there so many lessons in one test? Well, it's not a lot, it's only 12 lessons. 12 lessons. Remember, we covered from lesson 1 all the way up to 12. 5, 6, 7, 8, 9, 10, 11, 12. The first lesson is about life, right? What is life? Second lesson is about biological organizations. So there are different ways of organizing life. You have to memorize the different terms and their definitions from biosphere all the way to atoms. So biological organizations. You also need to know a little bit about taxonomy, which is the way how biologists categorize different animals from the least specifics to the most specifics. The third lesson is the basic structure of atom. You need to know about proton, electron, and neutron. The fourth lesson is about octet rule and electron configuration. You know that electrons are put into the different levels of shells, and that because of the valence electrons, they can have different interactions. They share electrons, they give electrons, or they take away electrons. The fifth lesson that we will be tested on is bonding, right? Different type of bonding through electronegativity. So electronegativity, covalent bond, and hydrogen bond. The sixth lessons that we covered is the properties of water. So there are a few properties of water that you need to remember, such as hydrogen bond, the density of water, adhesion and cohesion, boiling points and melting points, so on and so forth. Properties of water. Lesson 7 is about biomolecules and functional groups, right? There are 4 functional groups that we've learned, and there are 4 biomolecules that we have learned. The 8th lesson is carbohydrates, the sugar family. The 9th lesson is lipid. Lesson 10 is about protein. Lesson 11 is about enzyme. And lesson 12 is really just an overview of all the 4 biomolecules that we have learned. And then we have lesson 13, which is the biocarb, so which is another review of all the biomolecules. Lesson 14 is a crossword puzzle, which is an overarching review from lesson 1 to lesson 12. So I guess that addressed the questions. Why are there so many lessons in one test? The next question is, could you go over all the bonds, such as ionic, hydrogen, polar, nonpolar, and covalent? Okay, good. This is a very good question. So let's first organize the relationship between them. You have ionic and covalent bond. So we will have to put these 3 bonds away. Let's first compare ionic and covalent. So this is what we call the bond. These are the real bonds that are being formed when you wanted to make either a molecule or a compound. Okay, so basically new substances from their elemental form. Atoms make bonds because they wanted to achieve octet rule in order to fill out their valence shell. So ionic bond happens when they become ions, when atoms becomes ions. They can have 2 types of ions. One is a positive ion, which is what we call a cation, or a negative ion, which is an anion. So when you have a cation, which is positively charged, and an anion, which is negatively charged, we know that opposite charge will attract each other. So they will come closer together, very close to each other, and the charge get neutralized. So at this time, they become a compound, which is basically two elements become ion and they group together and form some new stuff. So this is a compound. One classic example would be sodium. Sodium has one valence electron, right? Sodium has one valence electron, while chlorine has 7 valence electrons. So sodium wants to give away electron in order to have his valence shell filled, while chlorine will want to take in 1 electron in order to get its valence shell filled. If we look at this, we know that sodium would become a positively charged ion because now it has 1 less electron, while chlorine will become negatively charged because it now has 1 more electron. The two charge comes together because of opposite charge, they can attract together. At this particular moment, we said this is an ionic bond. Covalent bond happens when atoms share electrons. Atoms share electron. Covalent bond happens when two atoms have high valence electron. So maybe they have like 5, 6, 7. And they want to achieve their octet group. Basically have their valence shell filled. So let's say oxygen and oxygen. Both oxygen have 6 valence electrons. So 1, 2, 3, 4, 5, 6. This oxygen will also have 1, 2, 3, 4, 5, 6. So they will want to share the electron in order to have their valence shell filled. So this oxygen will come together with this oxygen together, and they're each going to contribute 1 electron to be shared at this common ground. So if I were to count the number of electrons right now, this will be 1, 2, 3, 4, 5, 6, 7 for the left hand side's oxygen. While at the right hand side, this oxygen will be 1, 2, 3, 4, 5, 6, 7. How many valence electrons would it need in order to achieve octet group? 8. They need 8 electrons. So this oxygen will recontribute their electron and share it again. So these electrons come here. So they each share another pair of electrons. Oxygen. So oxygen, oxygen. Calculate the number of valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So now both oxygen have 8 valence electrons. Both are happy. With this, they have created covalent bond, which is the sharing of electrons in between two atoms. And since we have 2 pairs of electrons being shared, this is a double bond. 2 pairs of electrons being shared, this is a double bond. If you only have 1 pair of electrons, it will be a single bond. When you have 2 different atoms, they could have different in electronegativity. Electronegativity is basically the desire to take electron, correct? So when I have 2 different atoms, for instance, oxygen, so oxygen and hydrogen, oxygen and hydrogen have different electronegativity. And we know that oxygen has a higher electronegativity than hydrogen. So when they are sharing electron will become closer to the hydrogen, right? When they're sharing electrons, oxygen will take in all the electrons from the hydrogen, right? The electron will be closer to oxygen. At this particular moment, we know that the electrons are not in the middle between hydrogen and oxygen, so there is an unequal sharing of electron. Unequal sharing of electron at where? At the covalent bond. At the covalent bond. Because covalent bond is the place where they share electron. And when oxygen has a higher electronegativity than hydrogen, oxygen is going to take in all the electrons. So this situation, we call this type of covalent bond a polar covalent bond. While in the previous example between 2 oxygen atoms, so this is oxygen atom, they are both oxygen, so they have the same electronegativity. Because they have the same electronegativity, their electrons will be right in the middle. There is an equal sharing of electron. their electron sharing is equal. Electron sharing is equal right in the middle. In this situation, we're going to call this covalent bond non-polar covalent bond. Okay, so now you get the sense between polar covalent bond and non-polar covalent bond. So let's review. There are two types of bond to make new substances, right? We know that bond is a reaction between two atoms that stick together to form something new. For instance, oxygen with two hydrogen, they come together, now they are water. It is not oxygen, not hydrogen. When you have sodium and chlorine come together, they become sodium chloride, which is the table salt. So there are two types of bond, ionic and covalent. Ionic is due to ion formation, and they come together because of their attractions between positive charge and negative charge. Covalent bond is formed due to sharing of electron. Okay? And sharing of electron can lead to an equal sharing or a not equal sharing due to the differences of electronegativity between the two atoms. The electronegativity. If the sharing is equal for the electron, we call this a non-polar covalent bond. If the sharing is not equal, we call this a polar covalent bond. Polar means differences in charge, right? They are opposite. So now the question is, what is hydrogen bond? Hydrogen bond is not really a bond. Hydrogen bond is more like an attraction. So hydrogen bond is not really a bond. It doesn't form something new. Hydrogen bond is an attraction between polar molecules. So basically a molecule that has a polar covalent bond. So a polar molecule is a molecule with a polar covalent bond. Polar covalent bond. So a classic example would be water. Because of the unequal sharing of electrons are now very near to oxygen. So oxygen is now negatively charged while hydrogen is positively charged. So let's draw another water molecule. Hydrogen is positively charged while oxygen is negatively charged. Why? Due to the polar covalent bond of water. So now oxygen is negatively charged because the electron is closer to oxygen. So this delta negative or delta positive, the symbol that looks like an S, we call this D delta. Okay? It means partially charged, slightly charged. Because of this charge, now they attract to each other. We usually use dotted line to represent the attractions between oxygen and hydrogen. This is the hydrogen bond. Or another way you can say is hydrogen attraction, but we still call it hydrogen bond. The name sticks. So the stronger the hydrogen bond, the stronger the attractions between two molecules. It means the molecules will become closer together. So attraction between molecule. Okay? So this is the difference between hydrogen bond and the normal bond to form something new. Whenever I said a keyword about two molecules attracting each other without forming something new, you know that it is hydrogen bond. When I say that some new substances is being formed, like let's say I have carbon, hydrogen, and oxygen come together, and now they form glucose. So you know that it is covalent bond. The key differences between ionic and covalent is that ionic is what we call a compound formation. You form a new compound. Whereas a covalent bond, you form a new molecule. So that is the key word that hints you which bond it is forming. Molecule and compound. So some people might ask me, why don't we focus on compound and ionic bond, but we put a lot of emphasis on covalent bond and the formation of molecule? Because this is a biology class. And biology class, we study a lot of molecules. because all biomolecules are made of molecules. We don't have biocompounds because life substances are based on carbon. Carbon has 4 valence electrons. So if you look at carbon, it can give away 4 electrons, or it can take in 4 electrons. Give 4 electrons, take 4 electrons. So that put carbon at a very awkward position because carbon can never form ions. It doesn't have a desire to form some sort of ions because none of it is easy. So carbon likes to share electrons. So carbon always forms covalent bond. And that's why we study more about covalent bond than ionic bond, and the focus are more on covalent bonds and molecules. So the next question is, can you explain how valence shell work at the first shell, second shell, and third shell? Very good question. So what is valence shell, and what is shell actually? So we know that the structure of an atom has a nucleus, and in this nucleus of an atom, nucleus has proton and neutron. So where do we put electron in an atom? So in between nucleus and the outer space of nucleus, we have this region called shell or energy level. It is where the electrons located at. So electrons are always surrounding nucleus, and it has its own energy level. So we call the location where electrons can be found the energy level. In other words, shell. Sometimes we also call it orbit. They kind of mean the same thing. It really means where we can find the electron surrounding the nucleus. And surprisingly, electrons are organized in a very organized matter. It doesn't just cram everything in one shell. It has different levels of organization. We start from the most inward shell, we call it the first energy level or first shell. And in this first energy level, it can only occupy 2 valence electrons, a maximum of 2. So once you put in 2 electrons in this valence shell, this energy shell, the remaining electron has to put into the other shells, the second shell. So the second shell has a maximum capacity of 8. So once you filled out the second energy level, you have to fill in the electron at the third energy level. The third energy level can actually have a maximum of 18 electrons, but for the sake of this class and how we built the octet rule model, let's just remember the maximum for the third shell is also 8. So the third energy level, to those who are in advanced chemistry class, I know that you know that the maximum capacity is actually 18, but because of some confusing energy level orbital structure thing, it kind of gets a bit wacky. But for the sake of our class, and for us to understand electronegativity and how atoms form ions, let's just imagine and assume the third energy level only has 8 electrons capacity. And we're moving on to the fourth shell. So this will be the fourth shell. If, let's say, for example, you have an atom that has, for instance, 12 electrons. You're going to put electrons into first shell, second shell, and third shell. So let's start filling the electrons into the first shell. In the first shell, the maximum capacity is only 2 electrons. So you start filling in the electrons. You put in 2 electrons. So once you put in 2 electrons from the 12 electrons that you have, now you only has 10 electrons left. You start putting the 10 electron in the second shell. In the second shell, the maximum capacity is actually 8. So you put all the 8 electron into the second shell. 8 electron. So you put in 8 electron into the second shell. The remaining electron is 2. So you start putting the remaining electron into the third shell. And the maximum capacity for that shell is 8. So if we look at this, we have filled up all of our electrons into the 3 shells. So the outermost shell, we call this the valence shell, which is the outermost shell. And we call the number of electrons at the outermost shell the valence electron. So how many valence electrons do I have in this model? There will be 2 valence electrons. So that's how you organize electron in the orbital, in the shells. The next question that I have is water a polar or non-polar molecule. So water is a polar molecule. Reason? Because water has electron very close to oxygen, because oxygen, this O, oxygen, has a very high electronegativity. If you still couldn't remember what electronegativity is and how do you determine whether an atom has a high electronegativity or low electronegativity, please check out my electronegativity video. So as compared to hydrogen, oxygen has a relatively high electronegativity. So oxygen will take in all the electrons from hydrogen. So all the electrons are going to attracted to oxygen. So now there is an unequal sharing of electron at the covalent bond. At this covalent bond, the sharing of the electrons, you can see that this electron is not at the center, it's very close to oxygen. So there's an unequal sharing of electron. That makes oxygen negative. So now oxygen is negative and hydrogen is positive. So water is a polar molecule. So next question is philic and phobic and hydrophilic and hydrophobic used in nouns? I do not know, but I can tell you is that philic and phobic are what we call a suffix, which means they can be attached into other words in order to describe something. Philic is a suffix that describes love or like or affinity, while phobic means hate, dislike, or fear. So there are a lot of English words that use these two suffixes in order to describe something. In our class, we learn hydrophilic and hydrophobic. Hydrophilic means love water, while hydrophobic means hate water or fear water. So now you will be wondering, why would people hate or fear water? Because everybody needs water to survive, right? Hydrophilic and hydrophobic literally means love water or hate water, but in real meaning, the ability to dissolve in water. Hydrophilic loves water, so it can dissolve in water. It can readily disappear when I put that stuff in water. So dissolve in water, while hydrophobic means unable to be dissolved by water. If you have salt, right, the table salt from kitchen, you put it into water, it will readily dissolve. So salt can be dissolved in water. So salt is hydrophilic. If I put the cooking oil or the olive oil into water, we know that you will form a surface of oil floating on water. It can never mix with water. It cannot mix or dissolve in water. So at this particular moment, we say that oil is hydrophobic. There are a lot of other examples where we know the substances is hydrophobic or hydrophilic. So the next question is, what is dehydration synthesis? So if we just look at the word dehydration synthesis, D stands for words like delete, destroy, deactivate. It means cancel, remove, removal, take it out. Hydration derives from water, hydrate, right? Something that's hydrate means something that's full of water. Hydration means water. So this means water. Synthesis means forming something, synthesizing. It means new things are being formed. New things form. So dehydration synthesis is a process which we build polymer or new molecules. Build polymer from monomer. Or we can build new macromolecules. So basically molecules that's really, really big from building block. Basically smaller substances or smaller molecules. So one classic example would be glucose. Glucose is the monomer for polysaccharides, right? Which is the polymer for carbohydrates. If you have a glucose, you put it next to another glucose, they will come together or form a new molecule. When they form a new molecule, they will always form a covalent bond. Remember this. A new molecule means a new covalent bond between two existing molecules. And dehydration synthesis says that whenever you form this covalent bond, a water molecule will be created. So a water will just magically come out from this covalent bond. So now you have a water in your hand. So this is dehydration synthesis. I just make a disaccharide. So basically 2 glucose molecule and water. From what? What did I use as the material to make disaccharide and water? I use 2 glucose. So glucose plus glucose, and I make it into disaccharide and water. The reactants for this chemical reaction is always simpler stuff, like monosaccharides, amino acids, the building blocks of triglycerides, or nucleotides. Those are like monomers. You always combine monomers and form something more complex, such as dimer, or disaccharides, or dipeptide, or dinucleotide, or even something even more complex, which is polysaccharide, polypeptide, polynucleotide. And whenever you make something more complex, you always form water. So in a dehydration synthesis, water is always your product. So how about hydrolysis? Hydrolysis is basically the reverse of dehydration synthesis. You take something that's very complex and you break them apart using water. Hydro means water and lysis means breaking down. So in this case, I'm just going to use disaccharide as an example. Disaccharide. So I'm going to use water as a reactant. And water is going to attack the bond and break disaccharides apart. So now glucose and glucose are being separated. In a hydrolysis reaction, water is always your reactant. So the next question I have here is, what is a carboxyl? Carboxyl is a functional group. So basically some sort of unique group of molecules that give some sort of properties to the molecules that they're attached to. There are 4 functional groups that you're going to learn. So functional group, carboxyl, carbonyl, hydroxyl, and the last one is amino. You need to know what is inside each of them. Carboxyl looks like this: carbon, double bond oxygen, single bond, and attached to a hydroxyl. This is a carboxyl group. The next one is carbonyl, which is just carbon with double bond oxygen. Following up is hydroxyl, which is just oxygen and hydrogen. And amino groups, which is a nitrogen with 2 hydrogen. You just need to recognize them. You don't really have to memorize them. Next question I have is triglycerides. So what is a triglyceride? If you cannot remember what is a triglycerides, please watch my video on triglycerides. Triglyceride is really under the family of lipid. The common name for triglyceride is like a fancy name for fat and oil. Whenever you say, hey, I need some olive oil or some cooking oil or some sunflower oils or butter, they are really just triglycerides. Triglyceride is a fancy name for the everyday butter that you eat. The formula or the structure of a triglyceride is a glycerol and 3 fatty acids. Remember, they are formed through dehydration synthesis, so they have a bond in between the glycerols and fatty acids, and they now form a new molecule, which is a triglyceride. So when you have a triglycerides, it means water molecules has been removed from glycerols and fatty acids. So the glycerols found in the triglyceride is not the same as the glycerols that you found without fatty acids. And remember that fatty acids are long-chain hydrocarbon. Hydrocarbons are a long chain of carbon that are being connected through covalent bond. The remaining atoms are just hydrogen being attached to this carbon chain. So this is what we call a hydrocarbon chain. And fatty acids has a carboxyl group, but that's not the main important point that makes this a fatty acid. Together, 3 fatty acids with 1 glycerol, you make a triglycerides, which is under the family of lipid, which is a fancy name for fat and oil. Next, what is a polypeptide bond? So we don't really have a polypeptide bond, we have a polypeptide. So poly means many, and peptide means something derived of protein. We know that protein is made of amino acids, so amino acids is the building block for protein. When you have a lot of amino acids being chained together through a covalent bond, through the formation of dehydration synthesis, we say that you have just formed a polypeptide. So polypeptide, the bond in between two amino acids. So these are all amino acids. AA means amino acid. Too lazy to write out all of them. So amino acids are being bonded together by a covalent bond formation. So when you have a covalent bond between two amino acids, we give it a very special name. Proteins are very cool, they are very diverse, so we give them a special name. This is a peptide bond. So peptide bond is really just the covalent bond in between two amino acids. The next question that I have is the special conditions of an enzyme to keep its shapes. So we know that enzymes have very special shapes. Enzymes are a type of protein, and proteins makes enzyme. Protein can also make antibody, as well as other different types of protein, such as channel protein, which we will learn more about it later. But protein is very diverse. They can make all sorts of different things. And in our today's lesson, we'll focus on mainly enzymes. So enzyme is the biocatalyst in our body that can speed out a reaction. How do they speed out the reactions? By lowering the activation energy of a reaction so that reactants can become products more easily. So in order to do that, enzymes needs to bind to the substrate, right? So this is an enzyme. It needs to be able to bind to its substrate. So this substrate needs to have some sort of very similar shape as the active site of an enzyme. So this is a substrate, which is a site that binds to the active site of the enzyme. So this is the active site of an enzyme, which is the binding site for the substrate, active site. In order for the enzyme to bind to a substrate, enzymes needs to be 3D. It needs to have holes in between. You know, you cannot just have a line, a linear line, a straight line to bind something. You need some sort of 3D shapes. In order to form that 3D shapes, enzymes, which is made of polypeptide, which is a long chain of amino acid, that needs to be able to fold and crumble and becomes like this. And when it becomes like this, you can see that now there's like different shapes and holes in between this long chain of fatty acids. So this is a 3D shapes. It has some sort of active site. And these are due to a few factors. You don't have to remember the factors, but just know that some of the factors are temperature, pH, and pressure. And they are very specific to different enzymes. Different enzymes have different conditions to maintain their 3D shapes. And when the 3D shapes is no longer maintained, we say that the proteins or the enzymes are a denaturation. And with that, I conclude my biology review. If you have more questions, feel free to check out my other videos. If you have questions on all the problems, I recommend you rewatch the video that I posted. As I said, the questions that I have in the review sheets are really the same questions as the videos that I have posted. And with that, I wish you good luck. Happy revision.